We'll walk through each course required for a bachelor's in electrical engineering. We'll discuss which courses are challenging, enjoyable, and what areas to focus on for success. A brief overview. This content comes from extensive experience across bachelor's, master's, and PhD studies in electrical engineering, including various internships and research projects. Math and Science Foundation. Calculus 1 introduces rates of change, essential for real-world physics applications. Chemistry Y covers basic principles, particularly atomic charges, although only partially relevant to electrical engineering. Intro to Computer Science offers fundamental computer science knowledge, beneficial for those interested in programming. Writing and general education courses build strong communication skills, which are crucial in engineering careers. Spring semester, advancing in math and physics. Calculus 2 builds on Calculus 1, introducing integrals and summation. Physics 1 focuses on mechanics, covering forces and motion, important for understanding large-scale engineering concepts. Intro to Engineering Concepts explores the broader impact of engineering on society. History, a unique general education course that brings a creative perspective. Fall semester, fundamental courses. Differential equations advances our calculus knowledge and is key for understanding complex circuit and system behaviors. Physics 2, electromagnetic physics, introduces electric fields, magnetic fields, and Maxwell's equations. Circuit analysis teaches us about resistors, capacitors, inductors, and voltage sources, forming a foundation for electronics. Digital Principles covers binary systems and logic gates, essential for building computer engineering and digital system skills. Spring semester, Advanced Math and Signals. Calculus 3 expands on Calculus 1 and 2 with multivariable calculus, important for three-dimensional applications in electromagnetic fields. Physics 3, Optics and Waves, focuses on wave behavior, diffraction, and optics. Engineering Computations introduces MATLAB, or possibly Python or C++, helping us with data visualization and computational skills. Signals and Systems brings in Fourier transforms, time and frequency domains, challenging but foundational for communication systems. Junior year, specialization in electrical engineering. Fall semester, electronics and electromagnetics. Electronics, I delves deeper into circuits, transistors and amplifiers. Applied electromagnetics expands on electromagnetic waves, transmission lines and RF circuits. Probability and statistics introduces concepts like Gaussian distribution and statistical processes, helping with data interpretation and predictions. Spring semester, circuits and communications. Electronics 2 builds on Electronics 1 with more advanced circuit applications. Communication systems introduces transmitter, channel and receiver concepts, forming a foundation for communication technologies. Embedded Systems offers hands-on experience with microcontrollers like Arduino, exploring sensors, actuators and real-world applications. Senior year, specialization and capstone. Fall semester, senior seminar and digital design. Senior seminar provides guidance for transitioning from academia to industry. HDL-based digital design enables us to program directly in hardware description language, or HDL, for designing digital circuits. Spring semester, capstone project and electives. Senior design project is a collaborative project applying knowledge gained throughout the program. Electives focus on advanced courses aligned with our interests, whether in RF, communications, or digital circuits. Internships, the key to practical experience. Real-world experience is essential. Internships each summer help us apply classroom knowledge in practical settings. When internships aren't available, related projects or part-time work can develop similar skills. Gaining experience through internships enhances our understanding of engineering applications beyond the classroom.